All right, hello, and welcome to our Kubeflow update. Thank you for joining and being at KubeCon 2020. I'm Josh Bottum, and I work as a Kubeflow Community Product Manager. And you can find me at joshbottom@arrikto.com. In our Kubeflow update today, we will go over Kubeflow 1.0. And then we'll give a brief update on what's coming in Kubeflow 1.1. We'll show a short demo of a workflow in Kubeflow, and then we'll discuss about what's coming after Kubeflow 1.1 and how to get involved with Kubeflow community. So the Kubeflow mission statement is a place that I like to start from. Kubeflow is designed to make it easy for everyone to develop, deploy, and manage a portable, distributed, and scalable ML system on Kubernetes. So that's a mouthful. Let's try to break that down a bit. Develop, deploy, and manage. You can think of that as I want to be able to develop a machine learning model in my Jupyter notebook. And then I'd like to be able to train, tune, and deploy that into production and have the tools to manage it. The ability to have it portable, distributed, and scalable. Portable meaning that I may want to have the same environment be able to work on my laptop, on-prem in a larger cluster, and then also in a public cloud environment. Distributed, inside of machine learning, at times you're going to want to use your infrastructure as effectively as possible. So you may have multiple nodes. You may have different capabilities on those nodes where you have GPUs or CPUs or lots of RAM. You want to make sure that you're placing your workloads appropriately in a distributed way. And then finally, scalable, where you may want to scale down to a single node or up to hundreds or even thousands of GPUs or CPUs, as well as gigabytes of storage or lots of RAM as well, petabytes of storage actually. And then an ML system on Kubernetes. So the important thing there is the ability to use Kubernetes effectively in the declarative operations, which allow you to leverage your infrastructure effectively at its higher utilization, as well as to minimize the operational overhead for the people that are managed that infrastructure. So this is the same mission that we've had since 2017, and we continue to deliver on it through the last 11 releases. Kubeflow is a collection of many different software components that allow you to build, train, and deploy a model. Let's walk through some of those components. First, you have the Jupyter Notebook, which provides that IDE experience that is an interactive tool that allows you to teach and share your work effectively. Many people really like Jupyter Notebooks. One thing that's special about Kubeflow Jupyter Notebooks is that they are, you do have isolation for them and authentication. So users are separated from each other, or they could share the same Kubernetes namespace. So you get the best of both worlds there when it comes to isolation and authentication. Training operators are important because inside of your ML training algorithms, such as TensorFlow, PyTorch, or XGBoost or MXNet, you will have the ML layer, the machine learning layer that has masters or workers or parameter servers and workers. Those have to be mapped into Kubernetes, master workers. And since any of those could be moving at any one time, any of the workers could be moving per Kubernetes, you need an operator, a Kubernetes CRD basically, that will move those workloads to the appropriate place at the appropriate time. Those are all delivered as part of Kubeflow, and it really does allow you to have distributed training, which speeds up your model processing time. Workflow building. These are tools that allow you to simplify the way that you build a Kubeflow pipeline and deploy it and run it. So typically in a Kubeflow pipeline, you have to build a containerized step for every pipeline step. And then you have to write some Kubeflow DSL, domain-specific language, to run those containers in the appropriate order. Kale and Faring basically simplify that process for you and make it go very much faster, saving the data scientist quite a bit of time. Kubeflow Pipelines is a way to schedule, run, and monitor a workflow that will run your machine learning model. So from time to time, you're going to have your machine learning model, and it will be receiving either new code or new data. And rather than building it again by hand, it's good to have a workflow that does that for you. Kubeflow Pipelines does that for you, and then allows you to schedule how that's run, to run it, and then monitor effectively. Data management is below the container storage interface on Kubeflow below Kubeflow, but it does provide the versioning, the sharing, and the reproducibility that all have been very popular and a basic building block. In order to do data science, you need to have a good data management layer. The tools involved: the hyperparameter tuning, the HB tuning, the TensorBoard, and the Prometheus give you tuning, allows you to take those hyperparameters and adjust them appropriately automatically through a series of algorithms, which saves you a bunch of time and makes your model run faster and more efficiently and more accurately. TensorBoard gives you a visualization of your data and your code. And then Prometheus allows you to have that infrastructure monitoring that allows you to better serve at the software layer below the machine learning layer. The metadata, very important layer that allows you to keep the artifacts and the parameters that are outside of the code, the ML code, and the data in a way that you can then reproduce your model and understand what's necessary to have that model capable for you in a future time, or reproducible in a future time. And then finally, KF serving. These serving tools, which we have three here: KF serving, Seldom Core, and TF serving, allow you to put your model into production consistently and efficiently. Seldom Core and TF serving are the more mature serving components. KF serving or Kubeflow serving is working to provide a simple interface for model serving and provide, with as few as 7 lines of YAML, you to deploy your model. And it's designed to provide a similar experience whether you're using TensorFlow or PyTorch or scikit-learn or XGBoost or others. KF serving is built on top of Istio and Knative, so that you can start with a simple configuration and add advanced security and load balancing. KF serving is designed from the ground up to speed model introduction with A/B testing, canaries, and auto scaling. The Kubeflow serving components are designed to leverage Kubernetes efficiently, to utilize infrastructure resources and declarative operations to minimize your manual operations. So that's a quick look at the components inside of Kubeflow. Let's continue down our path and look at what happened with Kubeflow 1.0. So Kubeflow 1.0 was our 8th release. It was delivered in March of 2020. As important of all the software deliveries that we did, which there were almost 200 issues that were delivered to improve the fit and finish, was the process that the community agreed upon. One was to publish a Kubeflow roadmap, which defines the features and timing for releases. We also have a versioning policy, which defines the maturity of the components, stable, beta, or alpha. We have delivered a stable applications requirement guide. And in this guide, it talks about what each components should address in order to become stable. So things like configuration and deployment, custom resources, logging and monitoring, Docker image, CI/CD, the documentation, ownership and maintenance, as well as user adoption. So in order to become stable, there's a checklist of things that each of the components should go through before they can claim to be stable. And then finally, we track everything in a GitHub Kanban board, which are available for folks to get to. These are all click-through links that you can use. Inside of 1.0, we've delivered these stable components now: central dashboard, the KF which is the command line, also the profile controller, notebooks, TF serving, training operators, both for TensorFlow and PyTorch, as well as the documentation. There are many components in the beta level, and many of them are maturing, and we'll talk about those as we get to 1.1. So that is a little bit on process that occurred at Kubeflow in 1.0. And I think the next probably 6 or 7 slides I'll go through quickly, but I wanted to give a feeling of who and why and what metrics people are using to measure their success with Kubeflow. So when we look at the Kubeflow 1.0 testimonials, many of these folks here are newer users to Kubeflow, but they're getting good benefits out of it. And you can see whether it's Dyson or US Bank or One Technologies or Group Buy or Volvo, that we've got a broad range of customers in different industries of different sizes, which is really interesting as a community because we get different kind of perspectives of what we should do. As a product management, people think about things differently. But when we also look at the success that the folks are having, so Dyson saying they expedite ideas from the lab to the bedside 3 times faster, or US Bank deliver material productivity enhancements, One Technology present the right product to the right customer at the right time, or Group Buy simplify very complicated deployments, and then in Volvo to be able to iterate and produce with ease is definitely a very good set of, I guess, comments from folks. Most of these folks have not been, with us since 2017, and many of them probably in the last 6 months have deployed and got benefits out of Kubeflow. So this is great news for folks that are coming in more recent times, right? And so Kubeflow, one of the things I do as a product manager is I take a survey about every 90 to 180 days of the users. This survey for 1.0 was the largest one we had. We had about 120 people respond at maximum. This one, we ask what best describes your roles, and you can see machine learning engineers are driving a lot of the comments in some of our largest user base at about 29%, about 23% from data scientists, and about 17% from software engineers and a smattering of other people. But it's good to know what the roles are of the folks that are coming and asking for either creating issues or asking for features. The other is how many people work in your organization. And you can see, about a large percentage here with more than 5,000 people, but almost 20% from 51 to 500. So you have kind of this difference of maybe an enterprise type customer, and then our second biggest set of users being this group, which is more, I would call a disruptor base. And, their capabilities and their needs may be the same, but at times they may be different. And how many data scientists in your organization? So you can see here that almost 50% of the organizations have less than 10 people. But again, you have some organizations that have over 100 data scientists. So if you have 10 data scientists or less, your needs may be a little bit different than if you have 100 data scientists. And then how do you use Kubeflow in your company? 24% just learning, 21% we're planning to use. a growing percent here at 30%. We're using it in development and 16% in production. So those are great numbers. We're really happy to see that progression. Now we're going to get into a couple slides on the metrics that you can use to kind of measure where you stand with your machine learning. This one talks about how long does it take to develop one model from idea to production. And you can see there's about 14% of the people that it takes 6 months, but 30% it takes about a quarter, and 25% takes a month. These guys that are doing it in about a month, that's maybe best in class. Not all models are the same, but it's good to know that if you want to produce a model, how long does it take to produce it from idea to production? And if you can do it in a month, that you're in with some of the best in class metrics that are out there today. And then how many models has your team developed in the last 6 months? You can see here that, about 34% have done 2 to 5, which means, less than one model a month. But you've got 11% that have done over 50 models. So we do know that there's folks that joined Kubeflow earlier and they have become more efficient with it. And I think that's some of the value of being an early adopter, is perhaps you get to be in this best in class group that's able to get the most out of Kubeflow. And then how often do you deploy models into production? And you can see here, again, every quarter about 21%, every month about 22 or 23%, and about 18% are able to do it every week. I talked to a customer just the other day who said that they wanted to deploy models into production every day. So I think we're driving in the right direction, and the model is helping people. And I thought this feedback would be good for folks to see. And then just looking at Kubeflow versus non-Kubeflow. So we had this question, and we did allow non-Kubeflow users in the survey. And you can see that Kubeflow users, so this is users that have developed more than 20 models. So these would be probably your best in class users. You can see that more Kubeflow users have developed models faster in 1 month than non-Kubeflow users, the same for those that did in 3 months. So the idea here is that the more that you have developing faster, probably the better. And that's what it seems like Kubeflow is doing from this analysis. Again, not that this is the end all be all, but it's a data point, and probably the best data point that we have in the market right now. Another study point here is what storage functionalities are required for AI and ML workloads. And what you can analyze is that versioning and model sharing have become two of the most important components, which makes sense, right? If you have data science, it's based on data management. You want to be able to version your models. You need to be able to share your models. And portability, still very respectable at 43%. I would just say we've been doing Kubeflow surveys for several, more than a year and a half, 2 years, I think it is now. This is the highest of any question we've ever had. Anything over 80% is really high for the community to be able to respond to. So I think it's something that folks do want to take a look at. One of the important things that we've tried to do inside of Kubeflow is to give an end-to-end user experience. So the tools that provide this, as I talked about before, one of them is called Fairing. Fairing allows you to develop, build, train, and deploy your models more efficiently using the Jupiter Lab notebook, the Fairing, as well as the jobs, CRDs, and Kubeflow serving. So this does provide you for an effective way to build and deploy, train, and deploy your models into production. Another CUJ that is an ecosystem CUJ is the Kale CUJ, also known as the notebooks, the pipeline CUJ. You can develop, create a pipeline, run it, and explore the pipeline later using Jupiter, Kale, and Rock, as well as Kubeflow pipelines and Rock to do some more exploration. We'll go through a quick demo of this a little bit later. But the real thing that I think folks get excited about when they look at this is that with these CUJs, you're able to reduce the number of steps necessary to deliver a model. And so when you look at the workflow steps, before having this capability, it would take you 24 steps, maybe hundreds of hours. And you might say, really, it's going to take me hundreds of hours? But in each time that you're building a pipeline, you need to have the data scientists write the code, and then they'll hand the code off to a data engineer or to a ML engineer, and probably an ML engineer. And the ML engineer will then take that code, put it into a container, put that container into a repo, write some pipelines DSL code, and then try to make sure that that pipeline will run effectively. With the new tools, with the touch of a button, the data scientist doesn't have to know anything about Kubernetes, Docker, or Kubeflow Pipelines DSL. It's all done for them automatically, and we'll give that in a demo here in just a sec. So this demo, we'll talk about how we annotate cells in a model. We'll snapshot the environment, we'll build a pipeline, we'll train it, and we'll run the ML model. Then we'll view the results and examine a pipeline step and iterate further. I know this is a lot, but the iterate further is actually very, very important inside of data science, because it will help you to make better models faster. So now I'm going to go over and do a screen share. This may take me a second to get this up and running. And I will go into a platform here. Hopefully you can see my screen. And I'm in the marketplace, which you can see from GCP. This particular environment will also run on your laptop, but there's an easy to use, get started program called MiniKF. That's had thousands, actually probably close to 15,000 users at this point. It's easy to use. You can see how I'm setting it up in the GCP platform. So if you have a GCP account, you can see how many clicks I've had to do to get to a place where now I can click this and deploy it. And in about 20 minutes, this whole environment will, maybe another couple clicks, it'll come up, and I will end up with an environment that looks like this. Right? So this is the Kubeflow central dashboard. Before I get to this, I will have to enter in a username and password. That whole system for username and password for authentication can be integrated in with your LDAP and AD environments using Istio and Dext. And many folks have done that integration to this point. You'll also see that there is a namespace here. This is a Kubernetes namespace, which keeps these folks isolated. So when I log in, I can either choose a namespace that is only to me, or I can pick one that I share with other data scientists. Over on this side over here, you can see those components that we talked about, the pipelines component, the notebook server, cattib, which is the hyperparameter, the artifact store, this is the metadata, volumes manager, as well as a snapshot store. You can see in the central dashboard, you have some quick shortcuts, some recent notebooks and documentation that are available. In the interest of time, I'm going to go in and start this demonstration. And so we'll show going in to create a notebook server. So in order to create a notebook, I can go in here and I basically come into this screen and I'm able to give this a name. We call it Titanic 1. You can see we have a namespace that we can give it to. So we have isolation. We're able to pick what custom image we want. This image could be anything from CPUs to GPUs using TensorFlow or PyTorch or whatever you happen to have in the custom image. Some are available for you right from the system. You have the ability to set your CPU and RAM for this notebook server so you can apply resources appropriately. And then the workspace volumes. This is where you'll keep your work, and you want to have the ability to keep your work and protect it. So in this, you have a workspace volume, which is for, as you would think, your code, and then a data volume, which is where you would put your data. We could call this data. You can give it a size, an amount path. Other things that are nice about Kubeflow notebooks is the configuration capability. So it's easy to get to external data sources using secrets or environmental variables, so you don't have to remember those. And then setting up GPUs is also made easy. From here, you can launch this. Once I launch it and click another button, I will get to a screen that looks like this. Okay, we're now coming into the Jupiter Lab, and you'll see here that the Jupiter Lab has come up, and you have the launcher screen that you're used to, and you have your notebook, your console capability, and other. We've gone in and worked to create, to download some examples into this, as well as some code. So these examples here, you can see we have a volume called data. Inside of data, inside of what we've downloaded using our terminal, is some examples, and you can see them here. And the one that we're going to go into is called Titanic. And as we bring this up, you can see that we have the Titanic machine learning model that predicts who will survive the Titanic passenger, which passengers will survive the Titanic shipwreck. So you're probably familiar with this. It's a very popular Kaggle model, and you've seen all these workflow steps before. What's a little bit unique that we've delivered is that we want to produce a pipeline that will look, I'll show you the cooked cake and then we'll come back, that will look like this, right? That will have a load data step, we'll have a pre-processing step, we'll do some feature engineering, and then we'll go through all these other machine learning algorithms, which will be trained, tested, and then deployed and used. And then we'll get some results on the data that we have. So we'll go back to the Jupiter Lab now and show how we can easily create those steps in using this code that we developed. So we'll turn on Kale, which Kale then allows us to identify the code that we want to be in our Kubeflow pipeline steps. And we do that by annotating each cell over here. This first cell is a special cell. It's called imports, so it won't be in our pipeline, but it is important as we get started. Then we go to load data. As you remember, you can see that this is a cell type pipeline step. It's called load data. It has no dependencies. And you can see that that is the first step in our Kubeflow pipeline. Then some of these steps in your code, as your data scientists will know, they're interesting, and you want to look at this data. Like, for example, you may want to know that more females survived than males, but it may not be something that you need as a Kubeflow pipeline step. So you may skip a lot of those steps, which this allows you to do, and then come to where you need to do some data preprocessing. So this may be your second step. And again, you can see this is a pipeline step. It depends on load data, and it's called data preprocessing. So any code or any cell below data preprocessing that has the same color is going to be used in this step and built into the container that will automatically build in a few minutes. And you can see as we preprocess the data, we're going to get rid of some missing data. We're going to account for that. And then we'll get to feature engineering. Feature engineering is another step that will be in our pipeline. We'll do some changing some sex into numeric or dropping some various features, age into category, fares into category. And then we get to the next steps, which are all our machine learning code and our different models that we'll run through. And those will be based upon that feature engineering step being done. And first we'll go through random forest. At the same time, we can be doing logistic regression, the Bayes, SVM, decision tree. And then the results will be based upon all of this. So let's just say that we get to a point where we've got our code and all our downloaded packages and libraries, as well as our data into a good state. And now we want to create a Kubeflow pipeline. Instead of having to take that and break up all that code, write Docker containers, upload them into a repo, and then write the pipeline DSL code to run them, all we have to do is hit compile and run over here. And what Kale will do with its backend snapshotting capability will take a snapshot of the environment. So these are all those persistent volumes that we used when we created the Kubeflow notebook. And then it will create the pipeline, it will upload the pipeline, and it will run the pipeline. So if we go and look at that, we can do a view of that pipeline being built here. And this will take a few minutes for this pipeline to run. But we will end up with a pipeline like what I showed you before. And this is a representation of not just the sequential steps that are happening, but the data flows. As when you're debugging, you want to know what your inputs and your outputs were, especially from a data perspective. And so this particular pipeline will take a few minutes to run. And why it's running, I just want to give kind of a shout out to the community. You know, I've been working in the Kubeflow community for some time. I've met a lot of people. I know that the folks that are the vendor folks, whether it's the Microsoft or Amazon, Google or IBM, become first name basis with these folks, and they do very interesting contributions, whether it's David Aronchek or Jeremy from Google or Amazon, the folks there, Ginseng, or the other folks, Animesh from IBM, Debo from Cisco, very much leaders in the organization. But I think even more importantly is the contributions that we see from the users, right? So we have folks from Bloomberg, Dan Sun, or from Gojex, William Pinter, or, you know, you take Terry from Ant Financial, who are doing great contributions into the Kubeflow community. And I think that's, when you go to the Kubeflow, help share their stories. So you can see that we built this model as we've gone through here, that load data step that we talked about. We've got the data pre-processing, the feature engineering, And now we're at this machine learning layer, which this will take a little bit, a bit of time, because we're actually going through and training the models with some data, and then we run through it again and we test it, and then we actually run the model and see what our accuracy scores are. And once those are all done, we sum all those up and put the results into a results tab, which we can then go in and look at and see what the results look like. They may be ready now. In the interest of time, I'm going to try to click in and see if those artifacts are ready. I think I should probably wait a little bit until this step says it's done, but let's see if it's ready yet. Oh, there it is. So if I go into the results tab and I look at the logs, you'll see here that although I think I might be smart, I may not be this smart. Each of my models came up with 100% accuracy. So I know that maybe I did something wrong. And now this is common in data science. Now I want to go back in and potentially figure out what I did wrong. So I can go into one of these steps, say the random forest step, and look at the artifacts that were created in this step. And in order to recreate that environment, I just click on that button as I did there. It takes me to my snapshot store, which happens to be integrated with a system called Rock. I can copy this file link here, and that allows me to recreate my environment. So if I go into my notebook server and create a new notebook and say that I want to continue to keep exploring, I can autofill this, call this random forest. Easy for me to type. And you can see I have my namespace, but all these other things, the image, the CPU and RAM, the workspace, the data volume, all these have been pre-filled in, and I can launch this. And in a few minutes, I'll bring up this random forest step from my pipeline, and I will be able to continue to iterate on that step with all the data and all the code and all the downloaded packages that I had when I first created this. This iteration capability is very important to data scientists who often make some form of mistake or challenge and then need to go back and improve their model. Or there's just new data comes in that they want to go through and take another look at and see how this impacts what they're doing. So you can see here, as we go through, it's bringing up that notebook as we had, and it will take me right to that random forest step, as you see, and all my data that I was using. This is actually a clone of the data that I had, so I can go ahead and start to use this. I can mutate it and not impact the original snapshot, but actually continue to keep iterating. With that, I'm going to go back and finish up that's the end of the demonstration. I'll go back to, the presentation and go back and just summarize what we saw. We annotated a notebook, cells of the notebook of a model. We snapshot the environment. We built the pipeline. We trained. We ran it. We reviewed the results. And then we examined the pipeline step and did further iteration. So this is good stuff, right? And now when we look at Kubeflow 1.1, which is now based for delivery in late July of 2020, what you'll see from the highlights is we'll have simplified ML workflows. So we've got more fairing improvements that are coming along, including the ability to set environmental variables and mount secrets, as well as the ability to set a config mapper. In Kale, we have some workflows that incorporate the ability to use multi-user pipelines and to tune a model efficiently and use cache steps. So as you're tuning a model, we'll run through that model maybe 50, 100 times, maybe more, in order to find the right hyperparameter settings for that model. You don't need to rerun all the steps of your model if you've already run them before in a Kubeflow pipeline. So if you use the cache steps, you can save processing time and save resources. Additionally, we have stable training operators for MXNet and XGBoost. This is fantastic for folks, especially in the financial industry, that use these types of algorithms in their models. We've improved the isolation and security, again, with multi-user pipelines, very popular request from folks. Private GKE and Anthos support, CVE scanning reports, so you can see the Docker containers that are used to run Kubeflow. You can see what the CVEs are there. And then namespace creation by administrators rather than self-service by users. That's just something that enterprise customers have asked for. And we continue to help build that foundation for GitOps installation and operations. And I think you'll see even more blueprint and KEP type integration as we go forward. And all this is tracked, as you can see, from the Kubeflow 1.1 Kanban board, which is available on this link. So what's next? Kubeflow Community Governance is big. We're going to have plenty of working groups that will be engaged and develop. The working group is more what you'd consider a SIG. And so we're in the process of defining how that governance works. And then Kubeflow 1.2 will be planned and started right after we get done with 1.1. So if you're interested in getting involved with Kubeflow, please feel free to join in. We have a great Slack channel. We have a Discuss mailing list that you can join. We have weekly community meetings every Tuesday. And then you can use the Slack channel or submit bugs on GitHub in the Kubeflow repos. We really wanted to give a big thank you to all the folks that have contributed to Kubeflow at this point, as well as all the users who either have contributed their time or effort, as well as just given us feedback. It's a great community, and we welcome a lot of folks. You can see almost 25% of the folks that come to the Kubeflow community are new, and that's been consistent since we started the community. So thanks a lot for your time, and we look forward to your questions. Okay, I think that's the end of the presentation. Definitely appreciate everybody listening. And as said before, very excited to see the growth in Kubeflow and to work with you.